So, in today's lecture, I want to give you a overview of this application development process. So, we have seen that applications play an important role in the whole setup. So, what are the various approaches that are available for developing the applications? We will see in that. Before we do that, let us have a discuss the overall system architecture. How does it how is the whole thing architected, the database and the other machines that interact with this database. So, one of the first things that were tried out was long ago, before even the PCs were born, there used to be mainframe systems, and then the centralized architecture was practiced, in the sense that all the complete DB functionality, the storage, running of the applications, transaction processing, concurrency control, all of that is on one system with the central server. And then the whatever the access systems are used to be dumb machines. So, they do not have much processing capability, they were just like terminals, right. So, that is the initial architecture, but nowadays we go for multi-tier kind of architectures. So, a basic client server architecture is what is we will use in this set of slides. So, we will talk about the two-tier kind of systems, where the client is reasonably powerful, and then it can do some local processing. So, typically PCs and workstations connect to databases. So, they can do since they can do some local processing, it is possible for us to run the user interface and even the application programs can be run on these systems. So, the client systems, and then they will be sending the database access request alone to the database server. So, the database server is the one that holds all the data, authenticates the users who are supposed to use the data, and then grants permissions to use, and also keeps track of all the modifications, all the complete functionality of databases, like this, taking care of the storage, transaction processing, and concurrency control, recovery, all that is in the server. Okay. So, this is one kind of popular architecture. You would also see, actually this is the basic kind of client server architecture. It is also possible for us to have three-tier architectures, where the middle layer actually has, and these applications are actually moved to the middle layer. So, the middle layer is called an application server layer, or even actually web server layer. So, the clients will do only will have only the user interfaces, they collect the parameters from the end users, and then invoke applications themselves run in the middle layer, and then the databases run in the last layer. So, the database servers will be in the last layer. So, that kind of multi-tier architectures also are possible. Now, the application we will for illustrating the principles, we will just take two-tier systems into consideration. So, we will call this whatever the language that in which the application is being developed as a host language. So, it can be typical like C, C++ or Java, and then we will discuss what are the various approaches that are there for managing this database access. Okay. Several approaches are available. Broadly, they are like this. embedded SQL approach, where SQL commands are embedded in the host language programs. This is in some sense a little static kind of approach. We will see why it is called a static approach. And there is a there are actually both are possible. Something called dynamic SQL also we will discuss within the same embedded SQL approach. Then we have there is something called call level interface, SQL CLI, call level interface. This is part of the SQL standard. So, this is a complete in API based approach, application program interface. So, there is a bunch of library programs, library function calls that are made available by the RDBMS vendors, right, and that will constitute the application program interface. So, using these API calls, it is possible for us to interact with the database. So, that is one approach, and we will see why that approach is some details about that approach. And then for the same kind of approach, if we are doing it through Java programming for Java, then we have what is called JDBC. It's an approach where we have an API through which connections to the database servers can be established, and then we can work with the database servers. So, I will to illustrate the principles, I will focus on some of these things. So, there is a third approach where you can even have a dedicated database programming language, a dedicated programming language itself can be used. So, the example for this is Oracle's PLSQL. There is a programming language / SQL they call it PLSQL. So, this is their own proprietary language which has been developed, it is a general purpose language developed with the purpose of developing database applications. Okay. So, this embedded SQL and dynamic SQL we will go into a little bit detail, in some detail. Other approach I will leave it to you to kind of study yourselves. Okay. There is one term that is called that is used in this context called impedance mismatch. So, this one actually the term itself comes from electronics kind of domain, because impedance is normally used in electronics circuits and things like that. But anyway, it basically what it talks about is it illustrates the problems that might arise due to the difference between the data model that is there in the host languages, typical programming languages, versus the database data models. Of course, you can see the differences are in kind of two forms. First thing is the data types of the host language and then the data types provided as part of SQL can be different, right. So, you can mostly of course, it is they are kind of one can map the various data types that are available in SQL to kind of nearest data types in the host languages. Another major thing is that the host languages typically cannot deal with a bunch of data records at a time. So, this is one major difference. See, SQL, when you give an SQL query to the database server, it gives you a bunch of tuples, a collection of tuples. Sometimes even it is a set, or sometimes it is a multi-set, right. So, a whole bunch of tuples will be returned to you. Now, whereas in a typical programming language scenario, you have if you are opening a file of records, you will open one by one and then operate with them, right. So, you do not have a means of handling a bunch of records at a time. So, we need to handle this. So, for handling this data type mismatches, basically for each of these SQL attribute data types that are possible in the standard, what are the corresponding high level language data types will be specified as part of some kind of a binding. It is called a language binding, and this language binding has to be done for all the host languages. It is more like an indication thing, saying that this is the nearest the host language data type that we can make use of. So, and in order to handle this query results issue, we need to kind of have some kind of a data structure and then provide some iterators, provide an iterator to go through those data structures. The data structure could be as simple as an array of records, and then you have to provide some mechanism to examine the rows of that particular array. So that is how we will handle this entire issue of impedance mismatch between the data model of relational databases versus the data model that is available in the typical imperative programming languages. Okay. So, with this kind of background, we will see how okay. So, one final point here is that this kind of a impedance mismatch will not arise if you are using a dedicated database programming language, because this would have been in some sense taken care at the designs of the programming language itself. The programming language will have constructs to handle a bunch of records coming from SQL queries and things like that. So this impedance mismatch does not arise in the case of dedicated database programming languages, but there are some downsides to using dedicated DB programming languages. Now, let us go let us look at what the one of the simple and easier to use approach, which is this embedded SQL. So, in this embedded SQL, we will again assume that there is a C, C++ or Java as one of the imperative languages as the host language or high level language, we will call it HL. What we do here is to embed SQL commands or statements interspersed in the programming in the program itself. Then of course, if you put SQL commands inside C programs, obviously the C compiler will crib and then it will throw it out, right. So, we need to have a pre-compiler. So, in order to distinguish these SQL commands that have been put inside the C program. So, what the pre-compiler, so you have to give some indication as to where the SQL commands start and things like that. So, we will use some reserved words like this exec SQL in order to indicate where SQL commands are coming in C programs, and a pre-compiler will replace all these segments where SQL commands have been put by an appropriate library function calls to the functions that are provided by the RDBMS vendors. So, if you are using a DB2 database provided by IBM vendor, then you will typically have the runtime, the library package that has been developed in order to handle this embedded SQL by the vendor, and that will be included in your it has to be included in your C program, and then the pre-compiler will replace all these segments where SQL commands have been used by appropriate function calls to these functions. Okay. So, that is how it will work. and the kind of data transfer from the database to your program will happen through specially declared host language variables. Okay. So, we will see how exactly this host will declare these things. Okay. So, these so you need a bunch of variables. So, you in order to be used in inside SQL commands, SQL statements, and so these will be declared as part of a special section. So, and these are these variables are called shared variables. Okay. So, let us look at this set of things here. This okay. This is a comment. So, this language should actually be here. So, this exec SQL begin declare section. So, this is where all the declarations have to be given, and you can see that these are the typical variable and arrays that are declared inside a C program. And these variables are available for your rest of the C program. You can assign values to them, you can make use of those values and all that. But they will also be used, they can also be used inside SQL commands, and if you use them inside the SQL commands, actually we should distinguish them, and then we will do that by actually putting a colon before these variables. Of course, notice that these variables have been declared keeping in mind the schema of the student relation that we have. So, all these variables will correspond to the attributes that are there in the student schema. So, when we use them in SQL statements, these variables names will be prefixed with a colon. So, colon roll number in an SQL command statement will basically refer to this particular roll number variable. And of course, in your C program, of course, you will use these shared variables as they are, right, without any colon and things like that. Okay. So, this is how shared variables can be used in order to basically pass data from your environment where your C program is running to the database environment basically. So, through these SQL commands. So, you will initiate these things in your program and then use them inside an SQL embedded SQL command, and then those values will be passed on to the database server. That is how the whole mechanism will work. Okay. So, let us look at some issues here. Now, one other thing that you have to be more worried about is the occurrence of errors. Okay. So, what if you have given an SQL command, but then there is some issue of in the data with the inside the database, and what you wanted to execute actually is not feasible for some reason. So, for this we have something called SQL state, which is a special kind of a variable through which the database server will indicate as to what happened when you gave this SQL command to that server. So, if everything is if the command is successfully run, then it will be set to 0. Otherwise, some non-zero value will be set, and that non-zero value will actually indicate to you as to what kind of an error has happened during the execution of the command. It is a string of 6 characters, and you need to actually declare this. So, SQL state is going to be set to some appropriate value by the RDBMS runtime system. Okay. After executing each of these commands. So, when your program is running, your You have issued an SQL command and it goes to the database server, the database tries to run it and there is some issue and then it will set this SQL state. So, this is part of the shared variables. So, it will set this value to appropriate thing, and so in your program after issuing each of these SQL commands, you must in the immediate next statement you must check what is the value of the SQL state. Is everything fine or is something wrong? If something is wrong, then you should program the appropriate sequence of actions based on that. So, non-zero values indicate errors in execution, and it is part of the standard as to what those non-zero values stand for and things like that. You must refer to the standard to figure out all that, and then based on that you should put some series of cases and things like that and then handle the situation. So, this SQL state is a special variable and it has to be declared in the declare section. I did not show it in the previous slide, but it has to be there in that as an array of 6 characters, as a string of 6 characters. Okay. So, this is how communication between the your program and the database server happens. So, database server indicates things to you through this SQL state. Now, before you start working with the database, it is required that you set up a connection to the database. It is required that you set up a connection. So, while doing that, you will be specifying as to what is the particular server which hosts this database, and then and your credentials. You have to authenticate. The application has to authenticate itself to the database server. So, it has to give the user name, password and things like that. And typically it is possible for the application program to kind of work with multiple database servers at a time, but at any point of time only one connection can be active. As far as embedded SQL is concerned, at any point of time only one connection can be active. That means you are connected to one database server at that particular point of time. Of course, you can, once you are done with that particular database, you can close that connection and then reconnect to another database. So, that is possible. So, these are the SQL commands that will handle these connections. So, connect to what is the server name, and then there will be a connection name that is going to be given for this particular kind of connection, and then immediately you will have to follow it up with authorization, in which you give a username, passwords and things like that. So, that you authenticate yourself. And then in order to kind of change to a different server, you would basically use this command to set connection to a new connection. Of course, you can disconnect. You have to disconnect from one server in order to, before you can connect to another server. Okay, so these are all part of developing the application program. So, before you do any actions, you basically set up a connection. Let us look at some examples of typical SQL statements, and then we will look at how to handle this query results and all that. Let us say suppose we collect the data through some graphical user interface into these variables. So, say roll number, student name, degree, year and all that. So, we have actually collected some data from the end user. Now, this has to be basically inserted into the database. So, you can issue a command like this. So, exec SQL insert. So, this is the standard SQL command to insert tuples into database. Now, we do not have a tuple of values, but instead those values are in these host language variables, right. In the host language variables we have set up those variables have been initiated for with these values, and so that is why you would give a typical command like this, insert into student table values. So, instead of giving directly values, you will give the variables that hold those values, and you notice that these variables are all having colon before that, because they are the shared variables that are being referred in the SQL commands. And then you will so this command would go to the database server, and it will try to insert it, and if you have not created the student table before, then it will crib obviously, and then you will have to check the SQL state to figure out what has happened after that. Now, let us look at handling query results, and in this context we will bring in a term called cursor into the picture. Though you will be able to handle a set of records in the sense of opening a file of records and then operating with that in a host language, we need some kind of a data structure to kind of receive these results from the database server. That is the whole issue about this mismatch. So, what is a cursor is basically is a mechanism which allows us to retrieve one row at a time, one tuple at a time from this result of a query. A cursor is required when you expect multiple tuples being returned by the thing. If you very well know that one tuple is going to come, then you actually do not need a cursor. Okay. So, for any SQL query we can declare a cursor, a cursor. So, as part of the embedded SQL commands we can declare a cursor for a particular SQL query. So, once you declare it, it will have a name, a cursor will have a name, and then you can use that name to kind of open that cursor. When you open the cursor, the SQL query will be sent to the database server, and then it will be executed. The results will be available in some time kind of a temporary storage, and then you can fetch those tuples and then move the cursor, etc., and then finally close it. So, when usually we will need this when the embedded statement is a select query that typically returns multiple tuples. Of course, the insert, delete, update, all these things they do not need a cursor because they are dealing with even if they deal with multiple rows, your input is unique for each of these things, right. So, you do not have to deal with the results from the database server. Okay, so here is a case where we do not need a cursor. So, here is select s name s dot sex into, look at this new clause. So, you can now give variables in your program which will receive these values into, and then you from student s where s dot roll number equals. So, you already have initiated the roll number variable with some specific roll number, and now you want to give this command saying that get me the name and sex values of this particular student. So, from student s dot roll number equals this particular roll number. So, the values. So, since roll number is a key, you know that you will only get one set of values, and so there is really no need for setting up any cursor for in this particular case, even though it is a query. Whereas, typically this is not the case in general, and you would require to declare what are called cursors. So, look at this query, select s dot name s dot degree from student x, where student sex is f. So, all name and degree details of girl students you are getting. So, obviously there are multiple rows, and so you cannot use this into approach because it is a problem. So, here is how you would handle that. So, here is a command where you are declaring the cursor for a particular query. So, it is called declare student info is the cursor name, and this is again a keyword cursor for, and then you give the query. So, once you declare this, it is there as a definition alone. Once only when you open it, if you give an open command, open the student info cursor, then the command actually goes to the database server, and then you get a bunch of tuples returned by the database server, and then they will be in some kind of a temporary storage. It is all handled by the handled by the embedded SQL approach now. So, the precompiler will take these things and then appropriately create library function calls to handle this kind of situation. Now, it will create some temporary storage and things like that, and then get ready to handle various commands related to cursors. Okay. Now, to read the current row of the values into the HL, the host language variables, you basically use this command fetch and then give the cursor name into and then a sequence of variable names, as many as there are columns in that particular thing. Now, after this fetch, then the cursor is pointed to the next row by default, but of course, you can actually control as to whether the cursor should move to the next one or should move to the previous one or should actually jump to the fifth one next or etcetera. So, all those things they are there as part of the cursor mechanism, but I have skipped mentioning them in the slides. But there are this command, the fetch command is actually much more complex than what I have shown you here. It can have optionally other parts where you can say that okay, after doing this you jump to the fifth row or something if you really need it like that. So, you can control the cursor as to where it goes. Yeah, it can be optionally controlled by the programmer. Then after reading all the records that have come, you can actually close the student command, I mean that particular cursor. So, this is how you kind of handle this situation that the database server typically returns set or multi-set of tuples, and then you have to make use of those values in your host language program. Maybe you will just simply display them or print them or something like that, but then you need to get hold of them. Or maybe you are actually examining each of them and then trying to figure out the next actions to be taken, etcetera. Okay. So, this is this is how embedded SQL typically works, and then let us move on to something called dynamic SQL, where okay. So, if you are using embedded SQL, then you know the SQL query or command to be given at the time of writing the program, at the time of writing the application program, you know what exactly is the command to be given. You may not know the exact parameters, okay, what roll number to give and things like that, that you may not know, that you will pick up from the host language variables which are initialized through some other function, and then but you know the command, right, that is what you will embed here in that. Okay. So, what if you actually, what if you do not know the kind of query that you need to pose to the database server? What if that query has to be figured out at runtime? So, this is one major issue, and in order to handle that, one simple approach that is as part of the embedded SQL is to do this. So, you have a so it will give you commands like prepare and then execute. Okay. So, I will show you some. So, basically what prepare does is to take a string, we called it SQL string here, but you can call it anything, take a string and then treat it as a query. Okay. So, it is a character string, and this prepare from will basically prepare some query called run queue from this string. Okay. And then if you give execute that thing, then that particular query will actually be executed, and then you will start getting the results, and then you can use cursors and things like that. Now, how do you so this particular string is actually a character string that is declared in your program, and in this case of course I will simply instantiate it with a constant string like this here, but this need not be the case. What you can typically do is you will check some various conditions and then probably interact with the end user, and then depending on the input that you get from the end user, you decide as to what are the tables from which the information is needed to be obtained, and then what are the conditions to be. So, you will actually dynamically form the query and then start putting characters into this SQL string to reflect that query. Get point? So, you will at runtime, after interacting with the end user, decide as to what is the query to be fired to the database server and formulate that query into a character string, and then use this prepare run queue from SQL query from that string and then say execute. So, why it is split into two, prepare and execute, is basically that you may want to run that query multiple times after having prepared it. Okay. So, that is why there is this separation. So, this is very briefly about this dynamic formation of SQL queries, which is actually very much required, because this makes your program highly flexible, in the sense it can handle the end user requests, various different kinds of end user requests, and then has the ability to dynamically form the query and then send it to the database server. Okay. Now, I will briefly touch upon the other approaches here, which are the API based approaches. So, before SQL CLI was there, then there was this ODBC, Open Database Connectivity, again function set of function calls, and then JDBC is also similar kind of a thing, which is mentioned, it is to be used for application programs being developed in Java. So, as against the embedded SQL approach, the approach here is to access the database through this API function calls, and who provides this APIs? Obviously, the database it is actually part of the standard SQL CLI and JDBC, ODBC. These are all standards. These are all standards. So, there are such a standard function calls that have functional calls have been standardized, and how you implement it will depend on your database system. So, each database management system vendor will implement exactly these function calls and then give you a database DBMS, I mean a JDBC driver for his or how for their system, right. So, the advantage of this using this approach is that it is pretty flexible. You can you can dynamically prepare SQL queries and things like that, and also many databases can be simultaneously accessed, and there is no restriction on how many number of active connections you can have with databases. And then of course, in order to use them you will require appropriate these drivers. These drivers are the ones that are provided by the RDBMS vendors, who will implement these standardized these SQL CLI and JDBC, they give you the templates for function calls. So, and those are implemented by the JDBA. Since they are standardized, so you can actually use your program to kind of access either a Oracle database or a DB2 database or any other database, as long as they provide you this JDBC or ODBC connectivity. Okay. So, typically how it goes is, so at runtime you select your data source, and then load the appropriate driver dynamically. Okay. So, you figure out that it is a you are interacting with an Oracle database, and then you will load the Oracle's a JDBC. Let us say you are writing a Java program, a JDBC driver, and then that will give. So, I am of course not giving details about this, but it has various function calls in which you can establish connections, you can manage connections, and all that. So, using those function calls you basically establish connections, authenticate yourself, authenticate the program, and basically then pipe the SQL commands that you want to actually, you may either have them statically with you, or you may dynamically prepare these SQL commands and things like that. So, you will pipe the SQL commands to them and then the close connections. So, this is a typical, this is kind of required, and this is how you work with these things. So, as a comparison between all these approaches, well, the embedded SQL approach is, the queries are part of the source code. So, actually syntax checking at the compile time is possible, right, and application programs are actually easy to understand because the SQL commands are also there as part of this as the thing there, and the development is somewhat easier. But then any changes to these queries, you will have to recompile the whole application, it has to go through this compilation cycle, generating the executable and all that. So, complex applications requiring runtime query creation are difficult to are not possible actually using embedded SQL. So, one has to go for API based approach for that. So, API based approach has flexibility, but then the applications yeah, and complex applications dealing with multiple database servers can be developed. Okay. And typically this kind of thing is required in practice. Supposing you are handling, let us say, accommodation requests for people coming in for some attending some event like a conference or something like that, and then in your you give choice for people to choose 2-3 accommodation options, and then and then you want to reserve some room for them as per their requests, see, and so each of these accommodation places are independent. So they will have their own database server to give you confirmation as they saying that yes, we have room, and then we will reserve this room for them. So in your application program you would be dynamically figuring out as to what is the hotel or accommodation place that a particular end user wants, and then you will try to establish a connection to that hotel database server, and that may be running in Oracle or DB2, you do not know, and then you will make the reservation, get the confirmation and things like that, and then go and do the confirmation to the end user. So in a typical scenario, practical scenarios, you will need to handle connections with multiple databases, and you need to dynamically prepare queries. So application development process is complex and also error prone. One has to check these application programs thoroughly before you launch. Of course, the DB programming language option is always there, but then of course there is no this impedance mismatch problems and things like that do not arise, because it is specifically developed for database programming. But then the downside of this is the programmers need to learn a brand new language. Okay. If you already know C and C++, then you cannot go comfortably go on developing database applications, but you need to now pick up this new language, which may be similar to existing languages, but it is still a new language. But another major issue is that you get locked to that programming language. Your application programs are not portable. That is the one major issue. Application programs become so these are typically provided only by yeah. So whoever provides, so you are kind of limited to that database language. You cannot use a general purpose language. So if you use a general purpose language, then you can move your application to another deal with another database server and things like that. So with this, these are the various issues. So you have to depending on the need of your application, you have to choose these approaches and then go ahead and then make use of it. The API based thing I obviously did not cover much, but because it has lot more details, then one has to pick up these details of the APIs. Okay. So with that, okay, we are closing SQL.